A circular economy is an industrial economy that promotes greater resource productivity, aiming to reduce waste and avoid pollution by design or intention, and in which material flows are of two types: biological nutrients, designed to re-enter the biosphere safely, and technical nutrients, which are designed to circulate at high quality in the production system without entering the biosphere, as well as being restorative and regenerative by design. This is contrast to a linear economy, which is a take, make, dispose model of production. Scope. The term encompasses more than the production and consumption of goods and services, including a shift from fossil fuels to the use of renewable energy, and the role of diversity as a characteristic of resilient and productive systems. It includes discussion of the role of money and finance as part of the wider debate, and some of its pioneers have called for a revamp of economic performance measurement tools. Origins. The concept of a circular economy, CE, has been first raised by two British environmental economists, Pearce and Turner, in Economics of Natural Resources and the Environment. They pointed out that a traditional open-ended economy was developed with no built-in tendency to recycle, which was reflected by treating the environment as a waste reservoir. The circular economy is grounded in the study of feedback-rich, nonlinear systems, particularly living systems. A major outcome of this is the notion of optimizing systems rather than components, or the notion of design for fit. As a generic notion, it draws from a number of more specific approaches, including cradle-to-cradle, biomimicry, industrial ecology, and the blue economy, most frequently described as a framework for thinking. Its supporters claim it is a coherent model that has value as part of a response to the end of the era of cheap oil and materials, moving away from the linear model. Linear, take, make, dispose, industrial processes and the lifestyles that feed on them deplete finite reserves to create products that end up in landfills or in incinerators. This realization triggered the thought process of a few scientists and thinkers, including Walter R. Starhill, an architect, economist, and a founding father of industrial sustainability, credited with having coined the expression cradle to cradle, in contrast with cradle to grave, illustrating our resource to waste way of functioning. In the late 1970s, Starhill worked on developing a closed-loop approach to production processes, co-founding the Product Life Institute in Geneva more than 25 years ago. In the UK, Steve D. Parker researched waste as a resource in the UK agricultural sector in 1982, developing novel closed-loop production systems mimicking and integrated with the symbiotic biological ecosystems they exploited. Emergence of the idea. In the 1976 Hannah Reekman research report to the European Commission, The Potential for Substituting Manpower for Energy, Walter Starhill and Genevieve Redday sketched the vision of an economy in loops, or circular economy, and its impact on job creation, economic competitiveness, resource savings, and waste prevention. The report was published in 1982 as the book Jobs for Tomorrow. The Potential for Substituting Manpower for Energy, considered as one of the first pragmatic and credible sustainability think tanks. The main goals of Starhill's Institute are product life extension, long-life goods, reconditioning activities, and waste prevention. It also insists on the importance of selling services rather than products, an idea referred to as the functional service economy, and sometimes put under the wider notion of performance economy, which also advocates more localization of economic activity. In broader terms, the circular approach is a framework that takes insights from living systems. It considers that our systems should work like organisms, processing nutrients that can be fed back into the cycle, whether biological or technical. Hence the closed loop, or regenerative terms usually associated with it. The generic circular economy label can be applied to, and claimed by, several different schools of thought that all gravitate around the same basic principles which they have refined in different ways. The idea itself, which is centered on taking insights from living systems, is hardly a new one and hence cannot be traced back to one precise date or author. Yet its practical applications to modern economic systems and industrial processes have gained momentum since the late 1970s, giving birth to four prominent movements, detailed below. The idea of circular material flows as a model for the economy was presented in 1966 by Kenneth E. Boulding in his paper, The Economics of the Coming Spaceship Earth. Promoting a circular economy was identified as national policy in China's 11th five-year plan, starting in 2006. The Ellen MacArthur Foundation, an independent charity established in 2010, has more recently outlined the economic opportunity of a circular economy as a part of its educational mission. The foundation has worked to bring together complementary schools of thought and create a coherent framework, thus giving the concept a wide exposure and appeal. Founding principles. Waste is food. Waste does not exist. The biological and technical components, nutrients, of a product are designed by intention to fit within a materials cycle, designed for disassembly and repurposing. The biological nutrients are non-toxic and can be simply composted. Technical nutrients, polymers, alloys, and other man-made materials are designed to be used again with minimal energy. Diversity is strength. Modularity, versatility and adaptiveness are to be prioritized in an uncertain and fast-evolving world. In working toward the circular economy, we should focus on longer-lasting products, developed for upgrade, aging and repair by considering strategies like emotionally durable design, diverse products, materials, and systems with many connections and scales are more resilient in the face of external shocks than systems built simply for efficiency. Energy must come from renewable sources. As in life, any system should ultimately aim to run on current sunshine and generate energy through renewable sources. The biosphere rules framework for closed-loop production identifies power autonomy as one of nature's principles for sustainable manufacturing. It requires that energy efficiency be first maximized so that renewable energy becomes economical. Systems thinking. The ability to understand how things influence one another within a whole. Elements are considered as fitting in their infrastructure, environment and social context, whilst a machine is also a system. Systems thinking usually refers to nonlinear systems. Systems where through feedback and imprecise starting conditions the outcome is not necessarily proportional to the input and where evolution of the system is possible. The system can display emergent properties. Examples of these systems are all living systems and any open systems such as meteorological systems or ocean currents. Even the orbits of the planets have nonlinear characteristics. Understanding a system is crucial when trying to decide and plan corrections in a system. Missing or misinterpreting the trends, flows, functions of, and human influences on our socio-ecological systems can result in disastrous results. In order to prevent errors in planning a design, an understanding of the system should be applied to the whole and to the details of the plan or design. The natural step created a set of systems conditions, or sustainability principles, that can be applied when designing for parts of a circular economy to ensure alignment with functions of the socio-ecological system. The concept of the circular economy has previously been expressed as the circulation of money versus goods. services, access rights, valuable documents, etc. In macroeconomics, this situation has been illustrated in many diagrams for money and goods circulation associated with social systems. As a system, various agencies or entities are connected by paths through which the various goods etc. pass in exchange for money. However, this situation is different from the circular economy described above, where the flow is unilinear, in only one direction. That is, until the recycled goods again are spread over the world. Prices or other feedback mechanisms should reflect real costs. In a circular economy, prices act as messages, and therefore need to reflect full costs in order to be effective. The full costs of negative externalities are revealed and taken into account, and perverse subsidies are removed. A lack of transparency on externalities acts as a barrier to the transmission to a circular economy. The circular economy framework. The circular economy is a framework that draws upon and encompasses principles from biomimicry. Janine Benyus, author of Biomimicry, Innovation Inspired by Nature, defines her approach as a new discipline that studies nature's best ideas and then imitates these designs and processes to solve human problems. Studying a leaf to invent a better solar cell is an example. I think of it as innovation inspired by nature. Biomimicry relies on three key principles. Nature as model. Biomimicry studies nature's models and emulates these forms, processes, systems, and strategies to solve human problems. Nature as measure. Biomimicry uses an ecological standard to judge the sustainability of our innovations. Nature as mentor. Biomimicry is a way of viewing and valuing nature. It introduces an era based not on what we can extract from the natural world, but what we can learn from it. Industrial ecology. Industrial ecology is the study of material and energy flows through industrial systems, focusing on connections between operators within the industrial ecosystem. This approach aims at creating closed-loop processes in which waste is seen as input, thus eliminating the notion of undesirable byproduct. Industrial ecology adopts a systemic, or holistic, point of view, designing production processes according to local ecological constraints whilst looking at their global impact from the outset, and attempting to shape them so they perform as close to living systems as possible. This framework is sometimes referred to as the science of sustainability, given its interdisciplinary nature, and its principles can also be applied in the services sector, with an emphasis on natural capital restoration. Industrial ecology also focuses on social well-being. Cradle to Cradle, created by Walter R. Starheel, a Swiss architect, who graduated from the Swiss Federal Institute of Technology Zurich in 1971. He has been influential in developing the field of sustainability by advocating service life extension of goods, reuse, repair, remanufacture, upgrade technologically philosophies as they apply to industrialized economies. He co-founded the Product Life Institute in Geneva, Switzerland, a consultancy devoted to developing sustainable strategies and policies. After receiving recognition for his prize-winning paper, The Product Life Factor, in 1982, his ideas and those of similar theorists led to what is now known as the circular economy, in which industry adopts the reuse and service life extension of goods as a strategy of waste prevention, regional job creation and resource efficiency in order to decouple wealth from resource consumption. That is, to dematerialize the industrial economy. Cooper, 2005, proposed a theoretical model to illustrate the significance of product lifespan in a progress towards sustainable consumption. The longer product lifespans could contribute to eco-efficiency and sufficiency. Thus, slowing the consumption in order to progress towards sustainable consumption. Blue economy. Initiated by former eCover CEO and Belgian businessman Gunter Pauli. The Blue Economy is an open-source movement bringing together concrete case studies, initially compiled in an eponymous report handed over to the Club of Rome. As the official manifesto states, using the resources available in cascading systems, the waste of one product becomes the input to create a new cash flow. Based on 21 founding principles, the Blue Economy insists on solutions being determined by the local environment and physical, ecological characteristics, parting the emphasis on gravity as the primary source of energy, a point that differentiates this school of thought from the others within the circular economy. The report, which doubles as the movement's manifesto, describes 100 innovations which can create 100 million jobs within the next 10 years, and provides many examples of winning South-South collaborative projects. Another original feature of this approach intent on promoting its hands-on focus towards the circular economy. In January 2012, a report was released entitled Towards the Circular Economy: Economic and Business Rationale for an Accelerated Transition. The report, commissioned by the Ellen MacArthur Foundation and developed by McKinsey & Company, was the first of its kind to consider the economic and business opportunity for the transition to a restorative, circular model. Using product case studies and economy-wide analysis, the report details the potential for significant benefits across the EU. It argues that a subset of the EU manufacturing sector could realize net materials cost savings worth up to $630 billion p.a. towards 2025, stimulating economic activity in the areas of product development, remanufacturing and refurbishment. Towards the circular economy also identified the key building blocks in making the transition to a circular economy, namely in skills in circular design and production, new business models, skills in building cascades and reverse cycles, and cross-cycle, cross-sector collaboration. In January 2015, a definitive guide to the circular economy was published by Coera with the specific aim to raise awareness amongst the general population of the environmental problems already being caused by our throwaway culture. Waste electrical and electronic equipment, WEE, in particular, is contributing to excessive use of landfill sites across the globe, in which society is both discarding valuable metals but also dumping toxic compounds that are polluting the surrounding land and water supplies. Mobile devices and computer hard drives typically contain valuable metals such as silver and copper, but also hazardous chemicals such as lead, mercury and cadmium. Consumers are unaware of the environmental significance of upgrading their mobile phones, for instance, on such a frequent basis, but could do much to encourage manufacturers to start to move away from the wasteful, polluting linear economy towards a sustainable circular economy. Impact in Europe. On 17 December 2012, the European Commission published a document entitled Manifesto for a Resource-Efficient Europe. This manifesto clearly stated that, in a world with growing pressures on resources and the environment, the EU has no choice but to go for the transition to a resource-efficient and ultimately regenerative circular economy. Furthermore, the document highlighted the importance of a systemic change in the use and recovery of resources in the economy, in ensuring future jobs and competitiveness, and outlined potential pathways to a circular economy in innovation and investment, regulation, tackling harmful subsidies, increasing opportunities for new business models, and setting clear targets. The European Environmental Research and Innovation Policy aims at supporting the transition to a circular economy in Europe. defining and driving the implementation of a transformative agenda to green the economy and the society as a whole, to achieve a truly sustainable development. Research and innovation in Europe are financially supported by the program Horizon 2020, which is also open to participation worldwide. The European Commission introduced a circular economy proposal in 2015. Historically, the policy debate in Brussels mainly focused on waste management, which is the second half of the cycle, and very little is said about the first half. Eco-design. To draw the attention of policymakers and other stakeholders to this loophole, the Eco This EU campaign was launched, raising awareness about the economic and environmental consequences of not including eco-design as part of the circular economy package. Circular business model. According to Linda and Williander, a circular business model is a business model in which the conceptual logic for value creation is based on utilizing the economic value retained in products after use in the production of new offerings. Mateusz Lewandowski provides a proposition to address this need to design circular business models, and presents a conceptualization of an extended framework called Circular Business Model Canvas, CBMC. The CBMC consists of 11 building blocks, adapted from Osterwalder and Pigner, encompassing not only traditional components with minor modifications, but also material loops and adaptation factors. Those building blocks allow the designing of a business model according to the principles of circular economy, and consists of 1. Value propositions, offered by circular products enabling product life extension, product-service system, virtualized services, and/or collaborative consumption. Moreover, this component comprises the incentives and benefits offered to the customers for bringing back used products. 2. Customer segments, directly linked with value proposition component. Value proposition design depicts the fit between value proposition and customer segments. 3. Channels, possibly virtualized through selling virtualized value proposition and delivering it also virtually. Selling non-virtualized value propositions via virtual channels, and communicating with customers virtually. 4. Customer relationships, underlying production on order and/or what customers decide, and social marketing strategies and relationships with community partners when Recycling 2.0 is implemented. 5. Revenue streams, relying on the value propositions and comprising payments for a circular product or service, or payments for delivered availability, usage, or performance related to the product-based service offered. Revenues may also pertain to the value of resources retrieved from material loops. 6. Key resources, choosing suppliers offering better performing materials. Virtualization of materials, resources allowing to regenerate and restore natural capital, and/or the resources obtained from customers or third parties meant to circulate in material loops, preferably closed. 7. Key activities, focused on increasing performance through good housekeeping, better process control, equipment modification and technology changes, sharing and virtualization, and on improving the design of the product to make it ready for material loops and becoming more eco-friendly. Key activities might also comprise lobbying. 8. Key partnerships, based on choosing and cooperating with partners along the value chain and supply chain, which support the circular economy. 9. Cost structure, reflecting financial changes made in other components of CBM, including the value of incentives for customers. Special evaluation criteria and accounting principles must be applied to this component. 10. Take-back system, the design of the take-back management system including channels and customer relations related to this system. 11. Adoption factors. Transition towards circular business model must be supported by various organizational capabilities and external factors. See also. References. 8. Consequential macroeconomics rationalizing about how our social system works. D. H. Chester. Published by Lambert Academic Publishing 2015. External links. The Ellen MacArthur Foundation. EU Circular Economy Strategy. The Product Life Institute. The Resource Event. The Circle Economy. McDonough Braungart Design Chemistry website. Biomimicry Institute. Blue Economy website. Towards the Circular Economy Report. RAP supports a circular economy. Turn to website. On the New Economy website.